Course 5, Redefining Environments. Course 5 came at a very challenging time for me. It began in the middle of my maternity leave, and when I returned to work after my 6 weeks, I was in catch-up mode, trying to figure out what the students had learned, rescheduling parent conferences that I had missed, and then writing report cards for a trimester during which I had been on leave half the time. I also needed to wait for our new science unit to begin before I could start work on my final coattail project. And, of course, I had a new baby to take care of at home. I am lucky enough to teach in a one-to-one iPad classroom, which was part of my motivation for doing Coattail in the first place. I also teach with Mick Hewitt, a former Coattail graduate who has already led the way in redesigning many of our units in the spirit of Coattail. Our e-coach is also Diana Bayobout, another Coattail graduate. Thanks to both of them, our students blog regularly, know about the importance of attribution, and have some knowledge of basic presentation guidelines. They have also had experience using apps such as Moxtra and Edmodo regularly for their schoolwork. This was important because I needed students to have some background in blogging and Moxtra to teach my unit effectively. When I was trying to think of a unit to redefine in Course 4, I decided that a science unit would lend itself most naturally to the use of technology. I was inspired to choose this unit because of a video posted on YouTube by Amy Dawn, a fellow grade 4 teacher who transformed her unit on decomposition by having her students use scientific tools such as digital scales and internal thermometers to gather data. We had taught this unit last year, with the major project being a decomposition experiment. Students were given 5 fruit or vegetable specimens and observed their decomposition process over a period of 2 to 3 weeks. The experience was valuable but limited to the observations that the students could make with their own 5 senses, sight and smell being the most obvious ones. My main goal for this project was to utilize technology during our decomposition experiment to more closely mimic the experience of being a scientist. I wanted my students to learn to use scientific tools to gather data. I also wanted them to understand the importance of using measurements when gathering data to form conclusions in science. We began our launch of this unit with an activity. As a quick pre-assessment, students went on a walk of the school campus, using their iPads to take photos of the living and non-living things that they saw. As with every unit, our excellent EAL teacher, Gwen Blaze, worked with us to help scaffold the vocabulary for this unit. She used a website called Quizlet to give students prior exposure to the vocabulary for the unit. We discussed what criteria determined an object as living or non-living once we came back from our walk. With support, students discovered that living things need to grow, take in nutrients, reproduce, breathe, excrete, move, and respond to their environments. To further solidify their understanding of living and non-living things, students watched a short video from PBS Learning Media entitled Is It Alive? It showed brief clips of different objects that students were asked to categorize as living or non-living based on the criteria we had discussed. Some interesting discussions resulted when students were presented with certain items. For example, would a seed be considered living or non-living? Students used both their paper notebooks and Moxtra to keep their work for this unit. In Moxtra, every student has his or her own binder in which they keep digital folders for each unit we study. They are then able to share these binders or folders with myself or anyone else they invite. We have used this app since the beginning of the year, and it is very useful since it can be used to store photos, audio clips, videos, and digital worksheets. Using Moxtra, students can annotate digital documents and then share them with their peers, parents, or teachers. As their teacher, I also have the option of annotating their documents right within the binder or leaving written or audio comments in response. We incorporated BrainPop videos extensively into the lessons for this unit. BrainPop videos starring Tim and Moby were popular with the students and served as a way to convey information that students found fun and interesting. For EAL students, BrainPop videos were helpful because the visuals and the closed captioning made it easier to understand the content that they needed to know for this unit. Once students were introduced to the concepts and vocabulary for the unit, we reviewed the scientific method, which students had been introduced to earlier in the year. Students were asked to number 1, ask a question, 2, state a hypothesis, 3, conduct the experiment, 4, analyze the results, and finally 5, make a conclusion. Before beginning the decomposition experiment, I wanted students to form hypotheses in response to the question, what will happen to the fruits and vegetables in our decomposition experiment? What factors affect the rate of decomposition? In order to activate prior knowledge, I had students watch a time-lapse video of a slice of watermelon decomposing over time. We watched it twice. The first time, students simply watched, and the second time, they made observations about what they noticed. Students were placed in 4 heterogeneous groups. Each group received a plastic container with a lid and the following specimens: an apple, a kiwi, a banana, a cherry tomato, and an onion. Students were allowed to bring in additional specimens to add to their containers if they chose. Groups were also allowed to add variables to their containers to find out how different factors affect rates of decomposition. 3 groups decided to keep their containers outdoors in the sun with the lid off, while the last group chose to keep their lid on and store their container in a cool, dark place. Additional variables that were added included water, vinegar, baking soda, and soil. Each group wrote its own hypothesis based on the variables that they had added to their container. I had a container that acted as the control. I had the same specimens as the students, but did not add anything to my container and left it in the classroom with the lid on. The objective here would be that the students would compare their own container to mine once the experiment was complete. I borrowed digital scales and internal thermometer probes from the secondary school to allow students to weigh each fruit and vegetable specimen, as well as take the internal temperature during their observations. We took our measurements every 2 to 3 days. Most of the students used their paper science notebooks to record their measurements because for most students it was faster to write by hand than to type the information into their iPads. So far, we have found that iPads are a great consumption device, but not as practical for production. Students did use their iPads to take photos for each day that they did an observation, and then stored them in their environments folder in Mockstra. Some students chose to do all of their observations in Mockstra. Students discovered that most of their specimens were losing weight as time passed and that the internal temperature was rising. They correctly hypothesized that the loss in weight was mostly due to evaporation, but were not as sure about the temperature. The specimens also became predictably moldy and unpleasant as the weeks passed. We used plastic gloves to handle the specimens as many of them started to become covered with mold and infested by maggots.
We found that the onion looks normal, and we found out that the kiwi, the juice was coming out a lot because it was all squished together and bundled up. And I'm pretty sure it gained more juice. But most of the other ones look perfectly normal, like the onion.
Was that surprising to you guys?
Yeah, that was really surprising. I thought in the inside it would just be like all round like the outside, but on the outside.
Oh, I don't want to use a knife.
Yeah, I mean.
Oh my god.
Can you show me
kid?
What?
The orange. It's sick.
Walk on your glove. Walk on your glove.
I believe the majority of my students learned a lot from this unit and found it particularly fascinating. It was especially well suited to my EAL learners and kinesthetic learners who tend to get easily distracted and learn best when doing hands-on projects. If I were to do this again, I would have made this unit run alongside a short unit on measurement in math. This would have allowed students to review units and practice accuracy in measurement, using analog equipment this time rather than digital. I would also have asked students to create a line graph to chart the decreases in weight and increases in temperature, and discuss how students often use graphs to view data more clearly and to pick out correlations. I also would have liked to have made this unit a bit more autonomous. There were so many bits and pieces that students needed a lot of guidance and checking in on. However, by the end of the unit, most groups were able to independently gather data and write detailed observations about
Just
their
reactions. What did you guys think after seeing that under the microscope? Okay. Alfie,
It looked like it had other babies inside of it.
what made you think that?
Because it had black dots all over the place.
You noticed black dots on its body? Okay. Benny, what did you notice?
And it was like hairy. Like in some point of it, it was like a bit hairy.
Okay. Calvin?
I saw something inside the black thingy moving inside the maggot. I think it's like some
Babies.
like not babies but like heart and stuff.
Okay.
We finally dissected our specimens and took a few samples to look at under the microscope. My students found the maggot very fascinating, especially since it was still moving. Groups also took photos of their containers at the end of the experiment and compared them by projecting their final photos for the class. They discussed their hypotheses about how they thought their variables had affected the rate of decomposition of the fruits and vegetables. A few of the groups also had
Alfie, do you have a
scavengers
question?
come and pick at the specimens in their containers, another frequent occurrence when organisms decompose.
And there was like a beetle and the onion has one peck and the outside has turned more purple, but before it was like brown. And when we cut it open, this is the beetle. That's the beetle.
In order to reinforce the fact that decomposition is really just part of an endless cycle, we composted the leftover specimens by covering them with soil and planters. We hope to replant some of our seeds, which was another experiment for this unit, using this compost once it's ready. Some of my objectives were not met or have not been met yet. I did not succeed in having students take over the class Twitter account and tweet about our developments. I have not established the close relationship that I had planned with our blogging buddies in Dubai. Next steps will be to reach out to them and ask for comments on our blogs once all the students' posts are uploaded. Reflecting on it now, I can say that I am somewhat satisfied with the work that I have completed so far in this unit. It's still not finished. Students are writing up lab reports using the steps of the scientific method and their data so far. We also have scheduled a resident expert, the biology teacher at our secondary school, to come in and answer any remaining questions that our fourth graders may have about decomposition. However, I think if there is one thing that I've learned from Coattail so far, it's that every project we complete is not an end in and of itself. It's just a part of the process. The important thing is that we don't give up the learning journey. Thank you very much for watching my Course 5 Coattail final project.